Hello everyone, welcome to our basic calculus class. So this is our recorded session for continuity at a point. So our goal right now is to determine whether a given function is continuous or not, okay? So we will be formalizing the definition as follows. Let f of x be a real valued function and a be a real number. So we can say that the function f is continuous at a point x equals to a whenever these three conditions are satisfied. Okay? So here's our condition. So we have three set of conditions right now. Number one is f of a exists. Okay? Again, condition number one, f of a exists, meaning the function is defined at x equals to a. So again, under condition number one, we need to apply direct substitution. We need to evaluate the given function. Okay? If makapag-come up tayo sa isang specific value, that means masatisfy natin yung ating condition number one. Next, condition number two, limit of f of x as x approaches a exists. Okay? Meaning, there exists a limiting value as x approaches a. So under condition number two, we need to evaluate, okay, the limit of the given function for that specific constant, okay, kung ano nga ba yung ina-approach ng x natin. So if the answer or if the limit does not exist, meaning hindi masasatisfy ang ating condition number 2. Pero kapag nakapag-come up tayo sa isang specific value under condition number 2, kung meron tayong specific value for L, nasatisfy natin ang ating condition number 2. Next, condition number 3. The limit of f of x as x approaches a is equals to f of a, meaning the limiting value or the value of L is equal to the function value. So again, the value of L, in other words, the value of L is equal to the evaluated value. Okay? So any of these conditions, okay, if any of these conditions are not satisfied, at least one, automatically the function is discontinuous at the point x equals to a. So, considered lang siya as continuous kapag yung tatlong conditions na to ay nasatisfy natin. So, kapag may isa agad na hindi natin nasatisfy sa conditions natin, automatically discontinuous siya. Okay? So, let's try to answer our example number 1. Determine whether f of x equals to 4x squared plus x minus 2 is continuous at x equals to 1. Okay, so this is our point right now. X is equals to 1. So here's our condition. Okay, f of a exists, the limit exists, and the limit or the limiting value is equal to the function value. So let's use our discussion board. Okay, so let's answer example number 1. Okay, all right, so this is our example number 1. So determine whether the given function is continuous at point x equals to 1. So ito yung ating mga given conditions. Okay? So let's start with condition number 1. So again, f of a exists, meaning we need to apply direct substitution, okay, to double check or to check our condition number 1. So right now, x is equals to 1. So let's evaluate. Okay? So meaning we will use 1 as the value of x right now. So check natin kung meron tayong makukuha value. Okay? So let's plug in the value of x. So from 4x squared to 1 squared, okay, plus x or plus 1, and then copy the remaining term minus 2. Now let's simplify. This one will give us 4 times 1 squared. 1 squared is equals to 1. And then let's simplify the remaining terms. 1 minus 2 is equals to negative 1. Okay? So simplify. 4 times 1 is 4. And then copy the remaining term minus 1. Meaning, the value of f of 1 is equals to 4 minus 1, which is equal to 3. Alright? So, again, under condition number 1, alright, f of a exists. Okay? F of a is equals to 3. Okay? Now, nasatisfy na natin ang ating condition number 1. Now, how about condition number 2? Okay? So, condition number 2, limit, okay, of f of x as x approaches a exists. So, right now, let's try to determine the value of L right now. Okay, so for the limit of the given function, so meaning this one will give us limit of 4x squared plus x, okay, minus 2 as x approaches the given point or x approaches 1. Now let's check, meron ba tayo makukuha ang value sa ating condition number 2, okay? So again, this is polynomial function. So to determine the limit, let's apply direct substitution, okay? So let's substitute the value of c right now, okay? So which is equals to 1. So same then actually to sa previous step natin. So let's apply direct substitution. This one will give us 4 times x squared or 4 times 1 squared plus x or plus 1, and then copy the remaining term minus 2. So let's simplify. 4 times 1 squared, so that's 4 times 1. 1 squared is 1, okay? And then 1 minus 2 is negative 1. 4 times 1 is 4 minus 1. The answer is equals to 3. Alright, so meaning under condition number 2, the limit exists, okay? So the limit of the given function as x approaches 1, the answer is equals to 3. Now, how about condition number 3? So under condition number 3, a function is continuous if the limiting value is equal to the function value. Right now, here's the limiting value. Here's the value of L, and here's the value of, or here's the evaluated value, okay, or the function value. So right now, since equal, yung dalawang values na yan, that means the given function is continuous. So let's check our presentation, okay? All right. So again, under condition number 1, since f sub 1 results into a real number, which is 3, the function value exists. That's according to our previous solution. Now, in terms of the limit, using the limit laws, the limit exists since the result is a real number. So check ulit tayo dun. And then, notice that the function value, as seen in step number 1 or condition number 1, is equal to the limit value, as seen in condition number 2. Hence, the third condition is all satisfied. Now, if that's the case, satisfy lahat ng conditions natin. So, meaning, the given function f of x equals to 4x squared plus x minus 2 is continuous at x equals to 1. Okay, so meaning the given function is continuous at x equals to 1. Alright? Now, how about example number 2? Now this time, dear students, I encourage you to pause this video and then try to answer our example number 2. Alright, so let's double check our solution. So determine whether the given function f of x equals to x squared minus 9 all over x minus 3 is continuous at x equals to 3. So this is an example of rational function, okay? So again, for rationals, we need to avoid zero denominator, okay? Or values of x that will yield to an indeterminate or undefined terms, okay? So right now, here's our condition. So let's use our discussion board and then solve natin yung ating given example, okay? So example number 2, determine whether the given function is continuous at x equals to 3. So here's our conditions. So again, let's start with condition number 1. F of a exists, okay? Again, f of a exists, meaning we need to apply evaluation. So again, x right now is equals to 3. So meaning, under condition number 1, we need to solve f of 3. Alright, f of 3. Now, let's apply direct substitution, okay? So again, we have x squared. So this one will give us 3 squared, okay, minus 9 all over x minus 3, or 3 minus 3. So let's simplify. 3 squared is equals to 9. 9 minus 9, copy the remaining term, minus 9. And then 3 minus 3, so let's simplify it. So that's equal to 0. So meaning 9 minus 9 is 0. So this is indeterminate. Okay? So again, dividing by 0 is undefined. Okay? So this is indeterminate, guys. Okay? The numerator is 0. Now, yes, meron pa tayong 2 remaining conditions in terms of limit and the limiting value. Equal ba siya sa kanyang function value? Again, guys, for continuous function, we need to consider the following conditions. Dapat 3 conditions yan. So since, okay, f sub 3 is undefined or indeterminate, the function value is seen to be not defined at x equals to 3. Okay? Now, if that's the case, automatically, we already have a condition that is not satisfied. We can already conclude that the given function is discontinuous at x equals to 3. Okay? So meaning guys, once nasa step number 1 pa lang or condition number 1 pa lang, hindi na natin siya na-satisfy, pwede na tayong tumigil doon. Okay? So automatically, the given function is discontinuous. Alright? So hopefully, same ang ating naging solution. Okay? Next, example number 3. Okay? So again, this is our note ha. Note that there is no need to proceed with the remaining conditions since continuity requires all conditions to be satisfied. Okay? Next, example number 3. How about piecewise function? Okay? So again, guys, please pause this video and then try to answer example number 3. Alright, so let's double check our solution, guys. Okay? So determine whether f of x, okay, a piecewise function, negative 2x plus 4 if x is greater than or equal to 3, and x minus 1 if x is less than 3, is continuous at x equals to 3. Okay? So again, same procedure. Let's use our discussion board. Okay? And then let's try to solve example number 3. Alright. So example number 3, right now, meron tayong piecewise function. Okay? So here's our conditions. And alright. So right now, the value of x is equals to 3. Okay? So continuous ba ang ating given piecewise function at x equals to 3? So let's double check. Okay? So let's start with condition number 1. F of a exists. Okay? F of a exists. So this time, let's use 3. Okay? So we first let's try to substitute the value of 3. So f of 3. Yan. So right now, 3 okay, meaning we will use negative 2x plus 4 for this one, okay? Because according to the piecewise function, we will use this function, we will consider this function if x is greater than or equal to 3, okay? So meaning we will use negative 2x plus 4 for this one. So let's evaluate. Okay, so let's evaluate. Now, let's substitute the value of 3. So we have negative 2x or negative 2 times 3. And then copy the remaining term plus 4. Now, negative 2 times 3 is equal to negative 6. Then copy the remaining term plus 4. And then negative 6 plus 4, meaning guys, the value of f of 3 is equal to negative 2. And that's it, okay? So meaning f of a exists for this for the given piecewise function. Okay? F of 3 exists. Now, how about condition number 2? How about condition number 2, guys? Okay? So how about the limit of the given piecewise function as x approaches 3? Okay? So right now, we will first solve for the limit, okay, of the given function as x approaches 3 from the left hand side. Alright? So from the left hand side, meaning values sa left hand side ng ating given point, which is 3. So we will use x minus 1. Okay? Because we will use x minus 1 if x is less than 3. Okay? And then after that, of course, right hand side value yung ating sumunod na given function or equation or expression, sorry, which is negative 2x plus 4. Okay? So again, condition number 2 tayo. So right now, let's start with the limit. Okay? Limit of the given function, okay, or limit of f of x as x approaches 3. So let's start with the left hand side. Alright? So this one will give us, again, left hand side meaning less than 3. So we have x minus 1. Alright? We have x minus 1. So let's substitute the value of 3. Okay? So let's substitute. So x minus 1, meaning this one will give us x or 3 minus 1. So this is equals 3 minus 1 is equals to 2. Okay, so this is the value of L. Okay, so the value of the limit of the given function, okay, as x approaches 3 from the left hand side. Okay, now how about limit of the given function as x approaches 3 from the right hand side? Okay, so meaning sa right hand side naman tayo ni 3. So same pa rin, limit of the given function as x approaches 3, this time sa right hand side naman. So meaning values above positive 3. So we will consider the first expression. So we will use this expression if x is greater than or equal to 3. So this one will give us negative 2x and then plus 4. So same na to sa previous step natin, okay? So let's double check. So again, let's plug in 3. So this one will give us negative 2x or negative 2 times 3. And then copy the remaining term plus 4. Now let's simplify. Negative 2 times 3 is negative 6 and then plus 4. The answer right now is equals to negative 2. Alright, so this is our condition number 1 and condition number 2. Alright, now notice, dear students, that the left hand limit value is 2, right? This is the left hand limit value. And the right hand limit value is negative 2. Okay, so again, according to our discussion for about limits, if the left hand limit is not equal to the right hand limit, that means the limit does not exist. Okay, the limit does not exist. Hence, the limit is not defined at x equals to 3. Alright, so again, let's double check our solution or presentation. Okay, so for example number 3, okay, so sa ating first condition, since the function value is a real number, okay, the function is defined or the function value is defined. So the first condition is satisfied. While the second condition, okay, ito yung naging solution natin. So the left hand limit is 2 and then the right hand limit is negative 2, meaning the limit does not exist. So again, meaning guys, okay, since at this point we already have a condition that is not satisfied, which is condition number 2, we can already conclude that the function is discontinuous at x equals to 3. Okay, so the given piecewise function is discontinuous at x equals to 3. So yan, so that's our examples number 1, 2, and 3. Okay, so again, here's our technique. Okay, so hopefully tandaan natin itong mga terms ito, okay? So as a note, there are functions whose continuity can be identified based on their properties, okay? So kahit yung mga properties lang, pwede nating maging Q yun to determine whether the given function is continuous or not, okay? So number 1, for polynomial functions, they are continuous at any real number, okay? So that is applicable for all polynomial functions. So, yung mga simple polynomial function. Now, this is true since solving for the function value is the same as solving for the limit value. Same with our example number 1, right? So, which then results in both of them being equal. So, masasatisfy si condition number 1, condition number 2, and of course, condition number 3 agad. Okay, for polynomial function. Okay? So, ang examples ng polynomial function ay for example, linear function, yan, quadratic, and cubic, okay? Now, how about rationals, okay? For rational function, they are continuous at all real numbers that are in the domain of the given function. So when we say domain, part of the x value, okay? So ensuring that the real number is in the domain also guarantees the existence that the first condition needs, okay? So for rational function, we have this what we so called discontinuities, okay? So yun yung mga values of x that will make the denominator equal to 0. Okay? So automatically that's not part of the domain for rational function. So again, si rational function automatically siya ay continuous kapag yung point na given natin ay isang point na part ng kanyang domain. Okay? Next, how about radicals? Okay? Or radical functions or expressions or functions with radical sign. So for radical functions, meron tayong two condition. Number 1, if the index is an odd number. So when we say odd number, not divisible by 2. Okay? So yun yung mga cube roots, fifth roots, and so yung mga index na equal to 7, 9, 11, something like that. Okay? So they are continuous at any real number. Okay? So that's for radical functions. Kapag siya ay may index na odd number, continue siya at any real number. So this also applies or implies that to solve for the limit of odd index radical functions, you may just substitute directly. So you're allowed to use direct substitution, okay, to determine the evaluated value and the limit of that given function. Now, how about even index functions, okay, or radical functions? So if the index is even, example yan using square root, fourth root, sixth root, okay, or any index na divisible by 2, okay? So they are only continuous on all positive real numbers. Okay? So for odd index radical functions, we are also allowed to use a negative point for this one. Pero kay even, okay, index radical functions, kailangan po ay puro positive real numbers lang. Okay? So, we are allowed to use the following techniques para makasave tayo ng time and effort sa pag-determine kung ang isang function ba ay continuous or not. Okay? Next. So, I have here the different cases, okay? Pictures ng graphs, okay? Different cases of discontinuity. Okay? So, yung first set of graphs natin right now. So, this is an example of removable discontinuity. So, sa ibang mga reference, tinatawag din siyang um, whole, okay, discontinuity, okay, or break discontinuity, yan. So, ma-observe natin, meron siyang hole or gap sa ating given function. So, this is an example of removable discontinuity. And then this one is an example of jump discontinuity, okay? So, again, check the track of the graph, okay? So, kung itatrace natin yung x-axis, so, meron siyang corresponding x-axis. Kung i-continue natin siya, pero nagkaroon ng putol sa ating mismong graph. Kaya nga siya naging jump discontinuity. So there are also functions, okay, wherein, for example, we are asked to determine the left-hand limit, okay, or right-hand limit. So the limit approaches infinity. Pwede siyang positive infinity like this one, pwede ring negative infinity like this one, or kabilaan. So sa left-hand limit is positive and then the right-hand limit is negative, okay? So yung tinatawag nating infinite discontinuities. Alright? Now, ito yung three types of discontinuities natin. Okay? So, removable, jump, and infinite discontinuity. So, you can categorize discontinuities further based on what happens with one or more continuity condition. Okay? So, ito na yung mga techniques natin to determine kung ano nga bang type ng discontinuity meron ng isang given function. Number one, if the function value is not defined, okay, or the function, okay, does not satisfy the first condition, then the function is said to have a removable discontinuity. Okay? Again, what do you mean po, sir, sa first condition natin right now? So, again, if the function value is not defined, that means if we apply direct substitution, and then the result, let's say, is undefined or indeterminate, that means the given function, okay, ang given function natin ay merong removable discontinuity at that point. Okay? So, again, that's under case or condition number 1. So, pag failed automatically sa condition number 1, okay, that function, okay, have a removable discontinuity at that specific x value or point. Alright? Next. So, if the function value is defined, let's say the first condition is satisfied, but the limit exists and is not equal to the function value, diba? According to our conditions, so here's our conditions, okay? The first condition, f of a exists, meaning the evaluated value. So if we fail the first condition, meaning we have removable discontinuity. Now, let's say we the first condition satisfies. Okay, satisfy natin yung first condition. So the function value is defined, but the limit value, okay, is not equal to the evaluated value. Anong ibig sabihin nun? Okay? So, yes, that is still considered as removable. Okay? Considered pa rin siyang removable, pero if the limit does not exist, there are two possible types of discontinuity ang pwede mag-appear. Okay? Now, number one, okay, if the limit does not exist and the left and the right hand limit exists, okay, kung yung left hand limit and yung right hand limit exists, but aren't equal. Same with our example number 3, okay, for piecewise function, okay, meaning the function is said to have a jump essential discontinuity or jump discontinuity. Okay, again, for jump discontinuity, we have a function value, okay, and then for condition number 2, the limit does not exist, okay. So the left and the right hand limit exist but aren't equal. Okay, automatically the limit does not exist, right? Okay, but again, automatically in terms of its discontinuity, meron siyang jump discontinuity for that specific or at that specific point. Okay, now let's say the limit does not exist, and then the left and right hand limit is equal to positive or negative infinity. Okay, so meaning if the left hand limit and the right hand limit approaches infinity, if that's the case, of course, obvious na obvious yan, meaning that function is said to have an infinite essential discontinuity at that point. Okay? So, ito yung different types of discontinuity natin. So, again, last one, reviewin natin kung paano siya double check. Okay? So, if the function value is not defined, automatically, we have a removable discontinuity. Now, if the function value is defined but the limit exists and is not equal to the function value, okay, under the second condition, yes, we have a removable discontinuity. Possible yun. Pero, if the limit does not exist and the left hand limit and right hand limit are not equal, meaning that function is said to have a jump essential discontinuity. Now, let's say the limit does not exist and the left and the right hand limit is equal to positive or negative infinity. Meaning, meron naman siyang infinite essential discontinuity at that specific point. Now, let's review our example number 1 for this one, okay? This is actually our example number 2 for continuous function, okay? Or continuity of a function. Now, determine the type of discontinuity for f of x equals to x squared minus 9 all over x minus 3 at x equals to 3. Okay? So, right now, na-solve na natin to sa ating discussion board. Okay? So, automatically, if we apply direct substitution, according to our solution, sige, let's review our discussion board. So, this is our solution under example number 2. Okay? So, under condition number 1, if we apply direct substitution, the answer is indeterminate. Right? The answer is indeterminate. That means, according to our discussion, meaning, okay, since the first condition is the one that fails, which means that the function value is not defined at x equals to 3, hence this function has removable discontinuity at the set point. Okay? So that's a removable discontinuity. So meaning the graph of this function meron siyang hole or gap. Alright? Next. How about example number 2? So this is actually our example number 3. Okay? So determine the type of discontinuity for the given piecewise function at x equals to 3. So again, let's review our solution, no? So ano nga ba yung naging solution natin sa ating example number 3, okay? So for example number 3, okay, for that piecewise function, the evaluated value is equals to negative 2. So under condition number 1, we have a specific answer. Under condition number 1, the answer is negative 2. But the limit does not exist because the left hand limit, which is positive 2, is not equal to the right hand limit, which is negative 2. Okay? So again, if that's the case, according to our discussion, what type of discontinuity? So ano nga bang discontinuity ang meron tayo if that's the case? Again, this one will give us, okay, a jump essential discontinuity. Why? Because the left and right hand limits are not equal. Na-satisfy si condition number 1, but the left and the right hand limits are not equal. So because of this, the function is said to have a jump essential discontinuity at that said point, okay, at point x equals to 3. Okay? Next. How about example number 3? Now this time, I encourage your students to pause this video and then try to answer example number 3, okay? So let's determine if the given function is continuous at point at x equal to 0. And then after that, i-determine natin kung anong type of discontinuity ang meron siya. Alright, so let's double check our solution, okay? So, right now, the given function f of x equals to 1 all over x. So, this is automatically not continuous, right? Why? So let's check the condition, guys, okay? So, f of a exists, limit exists, and the limiting value is equal to the function value. Now, under condition number 1, automatically, if we apply direct substitution, this one will give us undefined term, okay, or 1 all over 0. So, obviously, if we apply direct substitution, yung denominator magiging 0. So, meaning this is not continuous, okay? So, how about the limit? Okay, here's my solution, okay? So, dividing by 0 is undefined. So, automatically, this is discontinuous. Okay. Now, let's figure out the type of discontinuity. Okay. So let's solve for the limit. So here's my solution. So the limit of 1 all over x as x approaches 0 from the left hand side. Guys, again, according to our discussion, left hand side and then the exponent of this denominator is 1. That's an odd number, meaning the answer is negative infinity. Okay, that is according to our discussion about limit laws. Okay, next, how about the limit of 1 all over x, the given function, as x approaches 0 from the right hand side? Again, from the right hand side, check the exponent of all or the degree of the given function or rational function. Guys, the answer is positive infinity. Okay, so this one satisfies, okay, our third type of discontinuity. So the given limits are not equal, meaning the limit does not exist. So the third condition is obviously not satisfied. Pero nasatisfy niya ang ating third type of discontinuity. So since both one-sided limits in number 2 or condition number 2 are infinite, then the function is said to have an infinite essential discontinuity at point x equal to 0. And that's it. Thank you so much, guys. Have a nice day, everyone, and God bless. Thank you.